Welcome back to Python Sweden, the workshop track. We're going to have right now the workshop on creative coding Python. Through the lens of the work they are doing at the imagiLabs, it will present an approach of teaching coding to children and teenagers in a way that engages girls in particular. She will explain how computer science and Python basics are normally taught as part of introductory computer science classes can be combined with creativity, self-expression, and a community in order to create a welcome environment and intriguing coding experience. She will show how they follow the constructionist and constructivist theories in education in which discovery learning, building knowledge, personal exploration, and relevant learning are instrumental. She will discuss how at imagiLabs they will develop a curriculum around these principles and define these on their, your own user-centered research. Finally, she will show some of their creative coding in Python activities in action. Come ready to get creative, get inspired, and learn how you can express yourself through code. Welcome, Beatriz Ionashko, the CTO of imagiLab. Thank you.
Thank you. So thank you so much for that introduction. You actually summarized what the part one of, of this session was about. So I had a 30-minute talk just earlier today that was about kind of how we teach Python at imagiLabs and what our curriculum is based on. And so this part is more of the hands-on part where we will just try some of the things that I talked about earlier. I assume that some of you have seen the previous talk and some of you probably haven't. So I'll do a mix of covering some of the things that I presented earlier, but also go slower so that you can follow along if you wish. And we'll try to cover some new things as well. So we will use the imagiLabs app in this session. So if you want to code along with me, I invite you to download the imagiLabs app on your phone. So we're going to be coding on our phones, and which is great because then you can watch on your laptop the session and code on your phone at the same time. While I give you a few minutes to download the apps, I will just take this time to introduce myself and imagiLabs very briefly for those of you who haven't seen the previous session. So I'm Beatrice, and I'm an engineer and an educator. And I get to do both engineering and education work at imagiLabs, which is an edtech startup that I co-founded. And we, at imagiLabs, we empower people who have never coded before, specifically preteen and teenage girls, to create with technology. So in this workshop, we will do that together, and you will see how it is to learn with imagiLabs. So I mentioned this term matrix coding that one of our users used to describe her experience of learning to code in our app, and she used this term because actually the coding is centered around this 8x8 pixel matrix. So when we introduce this, we often do it through an analogy with a chessboard, where in order to find the location of a piece on the board, you have to look at the numbers and the letters on the side of the board. And the same way for us to turn on a pixel, we have to specify the row index and the column index of that pixel. So this is how we turn on a single pixel, and this is how we can try to turn on several at the same time. So I won't code this. I will just show you the result because it's pretty straightforward. So we can turn on pixels one by one just by writing them on new lines. And the exciting part is when we start adding colors. So I can now also show you how to do some things in the app. By now, hopefully, some of you have managed to also download the app. So what you can see here in the screen is actually our Explore feed that's populated with different projects that different users have created. But if I go to Create in the middle and I start my own new project, there are some instructions here for me, and there's already one line written. So I can run this code, and there are no bugs hiding in my code. That's great. And then I can preview it directly here on my screen. So this is exactly what you saw on the slide earlier. But now the fun part that I wanted to show is the colors. So if I want to add some colors to this project, I have a special keyboard here that has different symbols, also some Python keywords, and the colors that I was looking for. So let's turn this pixel to aqua. This is one of my favorite colors. And now if I preview this, you see that this is now not white, which was the color that we chose for the on, but aqua. Okay, we can move on and look at some things here on the slides as well. So if we wanted to add some color to the emoji that we had before, we could do that this way. Or if we don't like these predefined colors that are available here, as I was showing you also in the keyboard, so these colors are actually environment variables or built-in variables that we defined before the user or outside of what the user sees in the editor in the app. So they are free to use them in any project. So anywhere I use any of these color variables, it will work. However, if I forgot to let's see, run the code and then preview. There we go. So now if I wanted to use something other than these colors, I could go ahead and create my own. And for that, we need to learn about RGB. So RGB is a color model that it explains how we can combine colors in a digital world. So it's a bit different from combining colors when you're in paint class, for example, when you combine physical colors. Here, when you combine all the primary colors, which are green, blue, and red, you get white. And when you don't have any colors, you end up with black or no light. So we can just look at this color wheel and some of these values. So in order to define any color, we have to decide or tell the computer how much red, how much green, and how much blue we want to have in this color. So for example, this shade of green on the left has a little bit of red, 42 red, 255 for green, and 1 for blue. And so on. We have a shade of red that is it's mostly red, of course, but also has a little bit of green and a little bit of blue. And then in the middle, we have white, which has maximum of all the colors. And then here's also an example of a shade of blue. We'll do a little quiz now. So 25500. What color is this? Well, remember the order was RGB. So this is the RGB code for red. Then this is the RGB code for blue, because we have, again, RGB, B is the last one. And then this is the code for green. If we want to create yellow, then we have to combine red and green. So red and green, let's see, it's this one at the bottom. Magenta, it's red and blue. So that will be the one in the middle. No green in magenta. And now we can use these colors, which are actually tuples. we can use them in our editor. So we can create our own colors, and I can do that here as well. I can check what these RGB codes that I have on the screen, if they are actually the these colors that I have on the preview. Let's see, if I go back to, I wasn't finding the parentheses, so I'll just type them from here. Let's see, 0, 40, and 255. If I run this and preview it, yeah, it looks like this is actually that shade of blue that we have on the preview as well. So now with the knowledge that we have, we can actually create a lot of different things, except for perhaps the animated ones, because we haven't talked about animations yet. So that will be the goal of this session, to create some interesting animations. But in order to kind of speed up the coding and to be able to do some more interesting things besides just individually setting the color of each pixel, we will introduce a few coding concepts. So the first one is a for loop, which we usually introduce by asking students to think about how they would program something like this, a rainbow. In order to program each individual light, we would have to write 64 lines of code, which is very time consuming. So instead, we could use a for loop that can either loop over the columns or the rows. In this case, we're looping over the columns and setting in each column, we are setting the pixels to the 8 colors that we chose here to have in our rainbow. So what we can do here, if we try it ourselves, so I think I have this project saved already. If I just open it, there we go. So what we encourage students to do after trying to write this code and running and seeing the result, we tell them to explore and to play around with what's written here in the code. So for example, I can play with this range, and now if I write, earlier I actually had only 8 written here, and that's because if I skip, if I only pass one number to the range function, then 0 will be taken as a default value for the beginning of the range. So it's equivalent to this. So let's say if I had this, I can run it, preview, just to make sure that we get the same result. And then I can start playing around with these values. So I can put a 2 here or a 3, and maybe I can put a, let's say, 5 here, see what happens. So now the range was shortened to 3 to 5, which tells me that the range has to do with something with the columns. So now I'm only turning on the column with index 3 and 4, as opposed to all the way from 0 to 8. So it means that the for loop is, I'm using that to iterate over the columns. But I still don't think I understand everything. So as a student, I might also make some other changes. And let's say if I changed this 7 here to be actually, let's see, to have the variable here, column, and then put the 7 here. Let's see what happens in that case. Okay, so my magenta row disappeared from here at the very bottom, and it's now here in the last column and rows, I guess, 3 and 4. And so that's because now instead of looping over the columns in range 3 and 5, I'm actually looping over these rows when it comes to placing the color magenta. So this is kind of the thinking that we try to encourage and our students to have, this exploratory approach where they can simply tinker with the code, try different things out, and see what happens in their code. Now, if we want to animate this, that's going to be actually very easy. But before we create this animated rainbow, I want to just show a simpler animation to get us started. So if we have just 2 pixels turned on, then I can write these 2 lines of code. So I have the pixel in the corner and the pixel at row 0, column 1, and they're both set to aqua. And then if I wanted to actually just have the second pixel flicker or blink, what I could do is this. So first of all, I create an animation object or instantiate the animation class, and then I use this class's method add frame to add the contents of my matrix M as a frame to the animation. Once I create an animation object in my code, the way we have set up this environment for in the app, it will automatically take and preview the animation for you. So let me try to also do this on my phone, and I invite you to also try this out on yourself. So yes, so this is the same code that I have on the slide. I can run it and preview it, and you can see that it's the same output. But why does it work the way it works? So let's say I don't really understand what's going on here. So what I can do is I can try to make some changes to the code. So for example, if I remove this frame here, and I just keep what I had before, 2 lines, run, then I end up with what I had before, where I had just turned on two pixels I set 2 pixels to aqua in M, and that's all I was looking at. I was looking at the values in the matrix M. So the same thing happened here, because even though I created an animation, I only added 1 frame to the animation. So then it just shows whatever is in that frame, which is equivalent to what's in M at that point. But if I had actually added the frame here, how it was before, okay. And let's take it out from the end here. Then I end up only with 1 pixel. And the reason for that is because in the moment where I add the frame right here in line 4, all I have in my matrix is actually just this 1 pixel in the corner. I turn on another pixel, but that is not added to the animation. And what I am displaying when I press preview is actually the contents of the animation. Something else I could do here, let's say in my second frame, I actually want to get rid of everything that was in the previous frame. So I can use a clear function. And now when I add this frame, the second frame to my animation, I will have a pixel that is alternating between the first position and the second position. So this is because I cleared what was in M before adding anything else to M and before adding the contents of M as a frame to my animation. So these are kind of like the basics. So I think now we can try to see how it would look like to create this animated rainbow. So it's actually, once you understand how animations work, it's actually very easy. We can add just the instantiation at the beginning. We create the animation object, and then in each iteration in the for loop, we add the current contents of M as a frame to the animation. Something I haven't talked about yet is functions. So functions come in very handy as well when we want to maybe create animations with different colors, or we want to have something that moves around. So in this case, I will show a smiley function, which contains the same code that I had before when I just created this smiley by programming each pixel. I have inside the function definition, I choose a color for the eyes and a color for the mouth. However, this is something that I can also do when I call the function, if I pass these variables as arguments to the function. So instead of just setting them inside, I use them as parameters, and then I can call the function with whatever colors I want for the eyes and the mouth. So I can swap the colors, and then I can also call this function with different colors repeatedly in an animation. So just like before, first I create the animation object, I define my function, and then I call the function with my chosen color parameters and add them as frames to the animation. So now with what we learned or what we covered, you are able to do pretty much everything that is here on this screen. Everything here uses either the animation framework or matrix coding, or in certain cases, different concepts like looping, conditionals, functions, and so on. I mentioned this in my previous talk, but it's really nice and interesting to see that what we teach and what we can program in this context can attract different types of people. So some of our users and some of the students that we worked with are more creative, and they prefer to create these art, like pieces of art and beautiful animations, where others are maybe prefer the more logical side of it, or like math, and they want to use it to come up with interesting applications in that direction. So here on the right side, you can see a dice that somebody programmed. And actually, this is one example that I want to go through in this session. So the way this dice was made is that we program the different faces for the dice that correspond to different numbers, and then we use the random library to generate a random number, and then show the corresponding face of the dice. So I will show this quickly on my phone. So here we are. This code was actually written by one of our interns, Lynn, so credits go to her at the top. We are very much about sharing and collaboration, and encourage users to credit other users or other students when they're using somebody else's code. So the first thing I do here is I import, well, actually, I only import the randint function from the random module. And I rename it to R because I'm typing on a screen, so I want it to be to fit on my screen. So I want a shorter name. And then we have this first function that defines a mark. So what it does, it actually creates the shape of any of these marks that are then used for the different faces of the dice. So it's 4 lines of code. Each of these corresponds to one of the pixels. And this function takes X, Y, and Z as arguments. So X is the either the row or the column index. I think the row index, and yes, the row index, then Y is the column index, and C is the color. So I set 4 pixels to color C. And then I move on to define a dice function where using several conditionals, I can decide where to place the marks depending on what number I pass as an argument to this function. So dice takes n and c as arguments. So n is the number that we will throw on the dice, and then c is again the color. So in the case of 1, we just have one mark here in the middle, starts at index 3, 3, so row 3, column 3. Then for in the case of 2, we have 2 marks. One is at starts at pixel with the pixel with row and column 1, and the other one is right here at 5, 5. And then so on for number 3, number 4, number 5, and until the end when we get to 6. Here we also have an else clause, which ignores if we pass any other number than n. Of course, you can do even more advanced error handling and check that n is indeed a number and so on. But these things can be added gradually. So of course, in the beginning, we just assume that okay, n will be 1, 2, 3, 4, 5, or 6. But as you keep exploring, you realize that it's important to handle for these situations that can occur, and that's actually how you would do it when you program for an application. You have to make sure that you check your inputs. And after we finish with this function definition, we go on to, let me just add some more new lines here so we can see. We move on to the animated part. So I again create an animation object. This time I'm using a list of colors. And here I created an animation with 10 frames. We don't have to do that. We could honestly just run this function without the animation and see what happens. So I could do that. I could comment out. Let's see, I can do something like this and comment out the last part. And before we move on to the animation, just call the dice function. So dice, and then I pass a random integer, so randint, I renamed it to r, between 1 and 6. And well, I could do a random color as well, but let's just make sure that this works fine, and I will just do a red color here. And if I run this code and preview it, there we go. So we got a 6. Let's run it one more time. Get a 2, and so on. You get it. Oh no, I'm not stuck. I'm actually just trying to run it one more time. Preview. Great. Okay, so that's how we would call the dice function. And then if we go back to the animated version, so what we have here, as I was explaining, we have a for loop that clears the matrix every time. Then it calls the dice function with the random integer and a random color from the list of colors, and adds that as a frame. So when I run this now and I preview it, I will have an animation with different the different faces of the dice. Okay, so I think I stopped watching the time, so maybe we have 1 minute for questions.
Yeah, it's okay if we pass the time. And we have a good question here. It says, is there some desktop version?
Yes, so you probably noticed that typing on the phone is maybe for especially for programmers, it's something that it wouldn't be your first thought. We do have a web app, so you can do this on the computer as well. The reason we started with the phone is because kids and teenagers are on their phones all the time. So we think that they should be doing something useful with the time they spend on their phones. But yes, we're building a web app as well, and it's in beta right now.
Okay, it was very nice talk, and I like it a lot. So I think that's it. Thank you for your talk, and thank you for your presentation. And now I invite everybody to join. The next talk is the lightning talks in the sequence for the workshops. Thank you, Beatrice. Thank you,
Thank you.
everybody.
Thank you.